Okay, gang, we're going to take a look at finding concavity for this equation. Concavity is the second derivative characteristic. It wants to know how the function is bending, whether it's concave up, holding water, or concave down, dropping water. So we have to go to the second derivative. I'm just going to go ahead and do it, find it by hand. Alright, derivative of 2 is 0. I got to watch the negative here. So the 2 is going to come down in front. I have to start by doing the derivative of the 2. Then I have to do the derivative of the secant, which is secant tan. Alright, let me make this look nicer now. Okay, they're on the interval from negative pi over 2 to pi over 2. Let me break this down into sines and cosines so I can just take a better look at it. I was going to put the square here, but it doesn't matter. I can put it down here. You could say the whole quantity squared or 1 over cosine squared. This would be sine of x over cosine x. Sometimes it's just easier to study the function if it's more in its elemental parts. So that's what you're watching me do. Because if I have to set the numerator or the denominator equal to 0, it's easiest in sine and cosine, particularly in this case. Okay, so now you have to find the critical points. Remember, the critical points are similar to the critical numbers. The exception being it's when we're talking about the second derivative equal to 0 or the second derivative being undefined. So it's the same thing as the critical number. It's just not the first derivative that we're referencing. It's when the second derivative is 0 or undefined. Okay, so let's go through that. For a fraction to be equal to 0, it means the numerator has to equal to 0. So the sign will equal to 0 on this restriction. If it helps, think of it as a unit circle. Think of the unit circle if it helps. Angle 0, angle pi over 2, pi, 3 pi over 2. Alright, so if you're stuck in between negative pi over 2 and pi over 2, you're not using any of this. You're allowed to go to pi over 2, so you can rotate this way. You're allowed to go to pi over 2, and you're allowed to go to negative pi over 2. So you're allowed to rotate like to these 3 spots. So you have to stay within this theta. So within that theta, sine will equal to 0 at 0, right in the center. At an angle of 0 falls in between here. So the first critical number here I have is 0. Alright, the cosine, that's for the undefined part. The cosine will equal to 0 at the endpoints, the negative pi over 2 and the pi over 2, but those aren't included because of these are open at the border. Okay, these are open at the boundary values, okay? Alright, so that is really the only critical point we have. Alright, so that's all I have to test because there's no other time that the sine equals to 0 under that restriction or that the cosine is equal to 0 under this restriction. So I'm good. So I'm now going to go ahead and test. I'm going to use like negative pi over 4. That's 45 degrees. Negative 45 degrees. And I'll use pi over 4, which is positive 45 degrees. If the radians get you a little bit, this is negative 90 and this is 90, okay? Now remember, when you're looking for concavity, you need to plug it into the second derivative. Now notice this is cubed, so this means the bottom can be positive or negative, the top can be positive or negative, and really important, This negative is also going to play a role. Don't lose that guy in the process. All right, here we go. Let's start with plugging in -45. You could technically plug it into any of these. I just find this the easiest, so I'm going to hang out here. All right, now I like to draw things. You probably learn my style by watching. I am very visual, which sometimes worries me because I don't always know what my mouth is doing because I'm not so auditory as I am visual. So if I draw -45 degrees, that means that the reference angle is actually 45 degrees. And you guys know that triangle, that's your 1, 1, radical 2. So what I'm trying to do right now is evaluate this. So I'm in quadrant 4, I've rotated down. The reference angle is always positive, so it's positive pi over 4. So I'm going to start to rattle this out. So the plus or minus of the sign in quadrant 4 is negative. So in terms of transferring it to the reference angle, it looks like this. Because the reference angle has to be positive. So if I convert it to a reference angle, it's 45 degrees on the reference, but it's negative because it's in quadrant 4. Right, so I'm making an equivalent statement here. All right, now the cosine, I'm going to use the reference angle on it. So it's cosine of 45 degrees, but in quadrant 4, the cosine is positive. I'll write it there just so you're with me. You're with what step I'm doing. I'm thinking to myself, okay, quadrant 4, the cosine's positive. I know I have to cube this all. Okay. All right, now I'm going to crunch it. I'm going to crunch out the numbers because I know the sides of this triangle. So it's -2 sine of 45. It's 1 opposite over hypotenuse. So it's 1 over radical 2. So it's -1 over radical 2. Okay, cosine of 45. That is the adjacent over the hypotenuse. So that's going to be 1 over radical 2 whole quantity cubed. Now, the good news here is that you just want to know if it's positive or negative. You don't care what the number is. All right, so in the numerator, I have a negative times a negative, which is positive. And in the denominator, I have a positive number cubed, which is positive. Let me just zoom in case you're having trouble seeing what I'm writing. So positive over a positive is positive, which means in this first quadrant, I'm positive. Now remember, this is the second derivative. So the second derivative, if the second derivative is positive, which it is, we're saying here the second derivative is positive, that means that it is concave up on this segment. It's concave up, it's holding water. All right, now we're going to do the same concept, but now over here for this one. So I'm going to use 45 degrees because that falls between 0 and pi over 2. Again, I'm plugging it into the second derivative, which I have here. Okay, I'm plugging it in. Now, it's going to be the same triangle, except we're going in quadrant 1. 45 degrees is in quadrant 1. So you're here now. Same thing, 1, 1, radical 2, but from quadrant 1, and you have to take account that your plus or minuses are different. Let me just move some of this information out of the way so I don't confuse you. Okay. All right. So, same game we just played. Let's do it again. You got the -2. You're stuck with that. Sine of 45. That's the opposite over the hypotenuse, and it's positive in quadrant 1. So I'm just going to write all the detail just to make sure we're on the same page. So that's going to give me sine of 45 is going to give me positive 1 over radical 2. Yes, it's being multiplied by -2. All right, cosine of 45. You're in quadrant 1. Cosine is the adjacent over the hypotenuse. In quadrant 1, that's positive. So it's positive 1 over radical 2 whole quantity cubed. Okay, and again, just like what happened before, we just want to know whether it's positive or negative. We don't actually care about the number. All right, so a negative times a positive is negative. The bottom is positive. So you have a negative over a positive. So overall, it's negative. So overall, this is negative in this particular segment. So we're saying that the second derivative is a negative value. Second derivative refers to the bending or the concavity of the graph. So that means for this segment, the graph is concave down. It's dropping water. It's bending downward. Okay, gang, that's it. That's all they want to know. If they had asked you and they didn't ask you, I'll finish writing out the answer. If they had asked you if this has an inflection point, what would have you said? Good. You would have said yes, because it changes concavity, which around a critical point, which makes it an inflection point. Okay, but let's write the answer nice now, okay? So for this problem, it's concave up. Now remember, when I'm referring to the original function. This means this research we did is telling me that the original function is concave up on the domain of negative pi over 2 to 0. And the original function is concave down from 0 to pi over 2. So always connect that the research that we do, the data gathering that we do, is telling us about the original function. Somebody's coming back and saying, oh, that person was wearing a green suit, right? So now we know something about that person. Here we found something out about the function, and we're just making note of it. Oh, the function is doing this, right? It's concave up from negative pi over 2 to 0, and it's concave up from 0 to pi over 2. Okay, that kind of idea. Concave down from 0 to pi over 2. Okay, gang, that's it. That's all they want for number 13. Hope that helped. Bye-bye.